This video shows our work on aerial robotic removal and installation of Stockbridge vibration dampers. Stockbridge vibration dampers are mechanical components that are used to reduce wind-induced oscillations in power lines. As they age, vibration dampers may fail and leave the power lines undampened. This leads to increased stresses between the conductor and transmission tower, which can ultimately lead to catastrophic failure and potentially power outages and wildfires. Installation and replacement of Stockbridge vibration dampers is typically performed manually by workers on the power lines. This is potentially unsafe for the workers and may require de-energizing the power lines before carrying out the work. Various robotic systems exist to perform maintenance on power line vibration dampers. However, these systems are typically large and require additional infrastructure to install them on the power line, adding cost and complexity. To address these issues, we propose a robotic system that consists of a pair of arms with which to land on the power line. The arms contain motorized wheels for traversing along the power line, a frame to support the propulsion system which allows the robot to deploy itself to the power line, a wire tensioning system to stiffen the frame, and finally the tool itself, which contains an impact wrench, a pivot to rotate the wrench, two linear axes to move the wrench in X and Z, and a third linear axis to lift and stabilize dampers. This test shows the uninstallation of a 10 kg Stockbridge vibration damper using the proposed system. The integrated propulsion system brings the robot to the power line, where it lands on the conductor using the two motorized wheel arms. The wheels are then used to align the robot with the vibration damper along the conductor, and the two linear stages of the tool itself are used to align the impact wrench socket in X and Z. The vibration damper lifter secures the robot onto the damper to prevent it from swinging relative to the tool frame. Once aligned, the operator issues the unfastening command from the ground station, and the impact wrench begins unfastening the bolt. Once the clamp is open and the damper detached, the robot rolls back to a safe takeoff location, takes off, and lands back on the ground. This second test shows the installation of a 10 kg Stockbridge vibration damper. Again, the integrated propulsion system brings the robot to the conductor where it lands using its two arms. It then rolls to the installation spot and starts raising the vibration damper. An L-shaped extension attached to the impact wrench is used as leverage to simultaneously rotate the vibration damper without the need for an additional actuator. Two clips on the vibration damper clamp keep the clamp open until the damper is hooked onto the conductor. Now, the impact wrench is aligned with the bolt, which is then fastened. The tool then disengages from the vibration damper and rolls away to the takeoff location, where it takes off and lands back on the ground.